Yo, what is up, guys? Girlfriend came this weekend, so couldn't stream Friday, Saturday, so I thought I'd start the stream today. Was gonna just do some OpenGL work on my own and chill out. I'm watching the Bears game right now over here, so if you can hear football going on. Bears game's on next to me, so but yeah, But yeah, damn. So I think what we're gonna do, we're gonna take a look at the LeetCode problem of the day, and then we're gonna do some more OpenGL. Probably get through a couple more episodes. I don't know what episodes I did on stream, but OpenGL playlist. We're getting through it. I don't think we've done anything since the last one. I just started learning about projection matrices and model view projection matrices. Have a rough idea. Was a little confusing, but I think it's the way that like the objects manipulated on the screen, in 3D or 2D. But I don't know. We'll kind of get back to that. Maybe I'll do a little bit more research. But it was a little bit confusing. But I think we'll probably try and do these 2 episodes today. I think that's the goal. But yeah, type shit. See how the Bears are going. They're on defense. All right. Okay, so given an integer array knobs, return the maximum possible sum of elements of the array such that it is divisible by 3. I think this is probably a dynamic programming problem. My honest first guess, I would probably say that. The reason why is... Let's play some Spotify, bro. I think like the reason why I think this is a dynamic programming problem is because it's just a sum, right? I mean, we could honestly n squared this, right? 56% acceptance, right? I mean, the brute force would be just a double for loop here, but what's going on here? Let's think about this, right? I mean, we can pick each number, right? Let's play some music. Fuck. How do I turn this stuff on, bro? Kind of sucks, bro. I can't play actual music, but I mean, it is what it is. But YouTube kicked me off live streaming last time I was playing, like, for my live playlist. The reason is here, why I think this is dynamic programming problem is because we can pick, right? We don't have to pick this one. We can pick this one. We can pick this one. I'm sure there's probably like some greedy solution to this, probably. Let's say DP, right? And I'm sure there's probably like a greedy solution, I would assume. I don't exactly know for sure, but I just have a feeling there probably is some sort of greedy solution. You can probably pick the ones that are like divisible by 3 or whatever, like, pick numbers that are divisible by 3. We'll steal this about school. But we're going to kind of go with the DP solution here. I'm going to go, first of all, with the backtracking approach here. 1, 2, 6, 2. Let's see here. Let's think about this, right? So let's do like a void backtracking function, right? We probably want to pass in vector of int references nums. We probably want a int I, right? we're gonna do the backtracking solution, just like the brute force backtracking to begin with. I think we want to return an integer here, so let's have like a int res 0, right? We can return the res here. Right, I would probably say if we just want to pass in nums, start with 0, right? And what we can do here is we can, you know, pick what we want to take, right? Let's think about it, right? So, what would our base case be? Well, you know, if I is greater than or equal to nums.size, right? Then we can just simply return, right? Because that obviously won't work, right? We need to check if it's divisible by 3. If it's divisible by 3, right? So if, I guess we need some sort of total. That actually probably would help, right? Int, let's call it cur total. I don't know, right? Our cur total starts off at 0, right? We don't want a reference to it, right? Or else then it won't work. Integer I. Yo, big dog, how are you, bro? What's up, Black Whiskey, bro? Yeah, dude, I'm good, bro. Just a little Sunday, bro. Watching the Bears game on the TV next to me. Gonna work. Gonna just do the Leetcode problem of the day and work on some OpenGL. Just chilling, dude. Okay. So if the current total is equal to, sorry, if cur total percent 3 is equal to 0. Sunday hustle, bro. Yeah, type shit, bro. Type shit. Just chilling, bro. I wasn't really gonna stream, but I was like, fuck it, you know, like I'm doing nothing else but watching the fucking Bears game. But cur total percent 3 is equal to 0, right? So it's divisible by 3. What do we want to do? We want to return the maximum possible sum of elements of the array, so it's divisible by 3. I guess we can just take the max here, right? So res is equal to max res and cur total, right? And then what do we want to do? We have two choices, right? We either increase, we either take it or we don't, right? So take it. Oh fuck, I'm thinking Python or something. Take it, right? We would go backtrack nums I plus 1. Then we just want to increase our total, right? So if we take it, we would go cur total plus I guess nums I, right? Current element we're looking at. How's your day been, bro? Black Whiskey, man. And then we skip it, right? Backtrack nums I plus 1, and we have the same cur total, right? And then int res here, we just return our res. We got 15 here. Case 0 is 0. Case 3 is 9. So we are missing something. I guess we're not adding the total, I guess, in the first go, right? I guess we can cur total nums I. That's why we're not getting it here, right? We're not adding the total here. So maybe what we can do is like, we can like add total first, right? Maybe like cur total plus or equal to nums I, right? We can pass in cur total here, but then we can minus it here. It's probably such a stupid way to do it, but they downloaded Battlefield, says Red, so I can enjoy it a little bit. Yeah, bro, I was just playing fucking Battlefield, dude. I was literally just playing, dude. I have 66 hours on the game, bro. I'm like level 70. It's fun as fuck. I'll probably play a little later too, bro. Sorry, cur total minus nums I, bro. That's what we need here. Oh, dude. $15 still, dude. So that's not gonna work. Let's get rid of that. Let's put this back. Output is 15. We're not adding the first 3. That's why. How can we add the first 3 here? How's it going, Crosshair Hero, dude? What's up, man? Good to see you again. It's going, dude. My girlfriend was here the past 2 days, so haven't really been programming or work on OpenGL or anything. But that's the goal today. Just finish this LeetCode problem, and then we're gonna do these 2 episodes. So I think I'm GUI and never done I'm GUI in C++, so that'll be new to me. And then I guess we'll be rendering multiple objects. Learning about that too. So. That's the goal, man. Let's go for today. Then I'll probably keep working on it later today, but then I think I'm gonna play some Battlefield with some friends, bro. First time I play Battlefield game, I don't know. I feel it's harder to spot enemies, but it's a lot harder than Warzone. Yeah, I mean, I agree. I mean, it's a tough game, dude. So I just like how smooth the game is, bro. I think they did a really good job with it. So trying to think here, bro. What am I doing wrong, bro? We're gonna need a DP here. Probably have to use some sort of hash map or something. I feel that my sister is in town, so I haven't done much either. Just spent time with family. You going to stream the games? I mean, dude, I've done it before. I've streamed Battlefield, I think, twice. I think in the past week. I don't know. I feel like most of my viewers are programmers and stuff. Maybe, I don't know. Most of the time I don't really get a lot of people, tuning in and stuff and, just chirping around. But, I mean, I can. Oh, shit, dude. Steelers scored, bro. Yeah, maybe, dude. I don't know. I mean, if that's what people want, I'm happy to stream games too. So, yeah. But kind of prefer to stream programming more, to be honest. Myself. I missed the last one. Alright, bro. I'll definitely stream later then. I mean, I'm definitely down. I play a lot of Battlefield, so it's kind of the only game I'm really playing right now, to be honest. But anyone kind of notice what I'm doing wrong here, bro? You got the multiplayer Battlefield 6 right, but I was talking about Battle Royale. Yeah, I got the multiplayer Battlefield 6. Yeah. I mean, that's what I play usually. I play Red Sec too. Like, I play Gauntlet, and I play Battle Royale with my friends and stuff. But I kind of prefer more the multiplayer. Like, my favorite game mode is Rush and Breakthrough. Those are probably my 2 favorite ones, to be honest. I'm not a really big like Conquest guy or anything like that, but right. This checks max, right? We backtrack. I'm just trying to think, like, what's the best way to do this, right? We could add it here, but we don't want to take it every time, right? Maybe we can start off with num's eye. Current total being num's eye. Let's see if that... Have you ever tried Rainbow Six Siege? Yes, I have. I used to play a shit ton of Rainbow, bro. Like, I have it on here, dude. Hang on, Rainbow, dude. Where's my Rainbow? Yeah. I got about 200 hours. I've played a lot of Counter-Strike, though, dude. I played a lot of Arma 3, bro. I have nearly 4,000 hours on this game. I have a lot of hours in Counter-Strike. This account's VAC banned though, but I have about 5,000 hours on Counter-Strike. I have like literally like 15 Steam accounts like with Counter-Strike. I used to cheat back in the day, but now I just play the game normally now, but back when I was a kid, so 3, 16, 4. What am I getting here now? 9. Dang, you're an OG. Yeah, bro. I'm kind of on status, bro. Like, shit, man. I bought this game. Bro, fuck. I got VAC banned on this account 3,865 fucking days ago, dude. Like, how long is that ago? 3,865 days from today. November. Oh, shit. Sorry. 350 days ago from today. April 18th, 2015, bro. I got VAC banned, bro. About 10 years ago, dude. So I've been playing Counter-Strike like 10 years, but I don't play a lot anymore, bro. Counter-Strike takes a lot of time, dude. I like just playing like games like Battlefield now, games I can just pick up, you know. No way, man. You were probably like 26, not that old. Lol. God damn. Yeah. No, I'm 24, dude. I'm 24. I just turned 24 a couple months ago. I started playing Counter-Strike when I was like 12 or 13, I think, bro, back when CSGO, CSGO came out, I think, in, 2013, I think, and that's around the time that I started playing. I think I started playing in 2014, I'm pretty sure. So, yeah. 0, 10 res. Yeah, man, I don't know what I'm doing wrong here in this, well, actually, no. Now I know what I'm doing wrong, right? I turn 30 next month. Oh, real long status, bro. Nah, bro. You're chilling, bro. You chilling. I'm gonna be... Yeah, bro. I feel kind of on status a little bit, too, sometimes, but... Little kids calling me an onk, bro. It is what it is, bro. I just enjoy spending time on the computer, dude. That's all I really care about. I plus 1, curve total plus nums I. Yeah, so I'm putting in nums 0 at first, but that obviously doesn't work because what if I don't want to take it, right? So, that's not going to work, right? Curve total plus or equal to nums I, right? We're not checking it here. Have to go here, right? Before we check the base case, right? We add our current total. Add our current total. Alright, get rid of this. What's your thoughts on CS2? The environment change plus recall and shit? Yeah, dude, I honestly don't have a lot of hours on CS2. I probably have played less than 50 hours on CS2. I was a huge fan of CSGO, but when it changed to CS2, I really didn't like it. It just felt different, and I used to be like level 10 on Faceit too, bro. I used to grind fucking Counter-Strike, bro. Use Reddit. A little bit, bro, man, just to look up random stuff. I'm not a regular Reddit user. Black Whiskey. Movement isn't anything like CSGO, but it's okay for me. Not a fan of the movement with shooting and that. There you go, bro. Crosshair says the same thing, dude. The fucking movement was so different, dude. That's what pissed me off. Take it, right? If we take it, then we would just current total, right? I plus 1. If we don't want it, we have to minus it. Curve total minus nums I. Okay, there we go. Okay, I'm not stupid. Okay, so I think this is the brute force solution here. This won't pass, but okay, good. We got it. Okay, we got the brute force solution. Here we go. Same here. Never played CS too much. Yeah, not a big fan of it, but okay. So we got the brute force solution. Right now, all we need to do is we need to add DP to this, right? So if we want to add some DP, right, we have to think about how we want to do this, right? I don't know how it's still on #1 most played games on Steam. Yeah, dude, it's fucking old too, bro. I don't understand either sometimes. Some people are like, oh, you want to play Counter-Strike? And that's like, fuck. To be honest, nowadays, dude, I'd rather play Siege than Counter-Strike. I just haven't really played in a really long time. Now, let's think about this, right? How do we want to add DP to this, right? So, we can do a hash map here. can map like maybe the current integer we're at to the current total. Maybe that would be good, right? So we could use some sort of like tuple or something. Let's come over here, right? I just need to look up the syntax for a I always fucking forget the syntax, bro. Like I'm so stupid, bro. I cannot remember the syntax for anything. C++ syntax for hash map. And I think here we were just going to return the integer value too. So it's going to be okay, yeah, you use a pair. That's what I thought. Okay, so let's create the hash map here. So we'll go unordered map, pair, int. I think from memory, shit. I think it's okay, I think this should be fine. I think we can go pair int and then int. Right, yeah. Sometimes I don't remember the difference between a pair and a tuple. Difference between, I'm just gonna look that up. Between pair and tuple. C++. STD tuple and STD pair use fixed equation homogeneous values, meaning values different types. The primary distinction lies in between the elements that they can hold. Meaning values of potentially different types. The primary distinction lies between the number of elements they can hold and how those elements to access. Stores exactly 2 elements. Tuple can store any number of elements. Okay, so a tuple can store any number of elements. A pair can only store 2. They're accessed using public number names first and second. Elements are accessed using std get index function. Okay. So there's not many scenarios. Be right back, dog. Okay, bro. Sounds good, man. Appreciate you guys tuning in on the stream, dude. Just chilling a little bit. We're gonna hopefully we get this problem done soon, so we can get to the OpenGL. We'll call this DP. I think that should be good, right? So we should be able to access that because it's a member function of this class, right? So we have a code total here. What do we want to do? Well, so if we've already been to this, right? Let's like do the caching part here, right? So we cache here. So if DP, I have to look up the unordered map, C++ documentation. We got a stud unordered map. How do we look it up again? It's count and find, right? Returns the number of elements matching the specific key, right? So I guess we can go, well, if dp.count, right? We're looking for the key value here. So the key being, dp.find, dp.count. How do we do this exactly? I don't know what the syntax should be. Okay, so dp, the syntax is this, dp.count. We pass in, well, we probably want our code total, right? So we probably want to add first, right? I would assume. Unless we're at this element. I guess that's an extra operation, but I don't think it's really going to matter that much, to be honest. Well, we'll leave it here for now. We can move it. I think this should be... we'll probably store the I value and then the current total that we're at, right? Shit, I think the Steelers just... Is that a pick six? Nope. The Bears are down, bro. 14-7, bro. What an L. Anyway, all right. Let's turn this music down a little bit. All right. Type shit. All right. Let's take a look here. So we have our cache here, right? So if we find it, we just want to return DP, DP I current total. I think that's how it works. Let's just make sure this is the syntax, because I'm not 100% sure. Okay, so I think that is the right syntax, but we are missing the colon, right? So this is our cache here, right? So if db.count, we return it, right? Otherwise, this is where we're updating here. We probably want to do like int take, right? And let's do like int skip, right? These actually return values now. Now we need to change the return type of this, I think, right? Or do we need to? Can we keep it as void? I don't know. DP kind of gets me fucking thinking all over the place, right? Okay, so this is fine, really. We either take or we skip, right? So, honestly, we probably just want the maximum value, right? So, I guess maybe we can just like do DP, like I per total is equal to the max of take and skip. And then I guess we can just return DP I cur total. Right, because we want the max value. This needs to change to an int. I guess we wouldn't even need a res anymore at this point. Maybe we just return backtrack. See what that gives us here. Nope. We're getting a... I guess we would just return 0. Nope. I'm missing something here. Hang on, let's think about this, right? Maybe we can keep this as void. Right, and we can just leave this. Turn DP. So we do need an integer, right? Or else this won't be able to return. Shit, we have to fucking think about this whole thing now. So obviously, okay. Let's return this. Get rid of that, right? If this is out, we want to return 0, I think, right? Add to the current total. We cache it. If the current total is %3, then fuck, dude. I'm honestly not sure how to think about this. It's so hard to think about the DP problem like this. I have a good idea about how to think about it sometimes, but I just... return backtrack num 0 0. In backtrack. If our base case here, return 0 when we get out of bounds, right? We need to fix this, right? Oh, something happened. This is our issue here, right? We have our res here, but this is our issue here. I just don't know what to do with this max value here. What should we store in here, right? Should we store our... Well, we are technically... Let's think about this, right? I'm honestly, I'm not sure, dude. I have to get some help here. Okay, so... Okay, so this is the better way to do it, it looks like. So instead of having this separate if check here... Something happened with the bears, dude. So here, we would go... We would return... the ternary operator here, curve total... This is probably a better way to go about it. %3 is equal to 0. If curve total, otherwise 0. So if the curve total is divisible by 3, we return curve total, otherwise we return 0. Right? Then we have our Memo here, right? So we can kind of get rid of this maybe. We have our cache here. We have our backtracking function that should increment by num's I. Kind of get rid of this. And we might have this issue again though, right? Otherwise we skip it, we keep our current total, and then we have the max, right? So instead of separately checking this right now, we're storing the current total that we're at, right? So that's the better way. That's what I was getting confused about mainly. We're missing something here. What are we missing here? Error non-void function. Oh, we probably just want to return this, right? Return dpij is equal to... Okay, so now we're getting a... So maybe instead of going to dpij, we do this, and then we just return dpij... Oh, sorry, dp curve total, not ij. Oops. Bro, I don't know what this means, bro. What the fuck does this mean, dude? I have to copy this. I don't know what this means. Maybe it's because we need to put this up here. We pass this in. DP, we pass this in as a reference here, so unordered map, pair, int, pair, whoops, int, int DP. This should be a... We need a reference here. Reference. Error expected name. After declaration clarifiers. Yeah, it has a fucking name, bro. What are you talking about? I'm doing something wrong here, I think. Alright, I'm just gonna copy this in text. Bro, what? Oh shit, why do I have a colon there? How the Bears going, dude? Someone got injured. Implicitly delete. Why do we have this, bro? Oh, I didn't delete it. Oh, no, I did. I did comment it out. Yeah, I am not sure why I'm getting this error here, bro. I do not know what this means. What does this mean? What's up, Niraj, dude? But you did not provide a hash function for the key pair in. So apparently you have to provide a hash function for this hash map. But I've never had to do this in Leetcode in my life, so... Convert the pair into a single 64-bit key. Fuck that, dude. Use a string as the key. Okay, I'm gonna try and use a map instead. I don't know if this is gonna work still, but I don't want a custom hash function, dude. Backtrack. Oh. Might be a C++ update if Leetcode just updated. Yeah, I don't know, dude. I've never had this issue before. It could be. The next thing I'll try is I'll use a different... Okay, there you go. So that works. Okay. I think we're chilling now. Is he gonna pass? Oh my god, dude. Okay. So maybe pair isn't the way to go. So maybe we have to go back to unordered map, right? Dude, this is so frustrating. So instead... So apparently the issue is that we need a hash function for the unordered map because it can't hash a pair of 2 ints, right? So instead of using a pair, maybe we can use a string, right? So let's do string. Right. I don't know if this is going to work, but I guess it's something we can try, right? String. So let's go through this one by one, right? So if I is greater than this, that's fine, right? If dp.count, how can we make this the, yeah, let's use this. Let's create the string key up here. String key, hang on. String key is equal to this, right? Then we can put in key here. So key, return dp key. We have key here. Key. Okay, let's see if this works now. Fuck, dude. Memory limit exceeded, dude. I don't know why this is not working, dude. Oh, we got the Bears, dude. I paused DP by value. That's my reason. Okay, holy shit, dude. I didn't know that was my reason. I paused DP by value. Is that gonna fix it? Nope. Pause DP by reference. I paused the DP by reference. Your recursion tree is 2 to the power of n. Even with miniaturization, your current total grows too large. The key's enormous DP becomes huge. I low-key hate that Leetcode defaults to using namespace STD because every single C++ version I never do that because of global namespace pollution reasons, and all the parameters don't have STD. Yeah, I mean, yeah, it is pretty annoying, but I mean, it's Leetcode for you, so. Here we go to Bez first down right here, bro. Holy shit. Dude, I did start DJ Moore and he got a touchdown, bro. What an L. Okay. So, they're saying that I should fix a string here, right? Then a memo on I current total %3 instead of full code total because sums mod 3 only have 3 states. This will TLE generate too many keys. Bro, dude. Sometimes Leetcode's so frustrating, bro. Went past my solution, dude. Oh my gosh, dude. Bless me. I knew this was a DP, I just couldn't implement it. Dude, yeah, I mean, me too, bro. I knew this was DP too. I did the backtracking solution, and then I added some DP, but now I'm getting a fucking TLE, bro. So GPT is saying, or Claude, sorry, I guess. Claude is saying that it's touchdown, bro. Let's go. So Claude is saying that apparently my keys can be too big. 2 to the power of n sizes. And if I potentially make this a better key, so using cur total %3, apparently this might pass, which I probably highly doubt, but I guess we can try it out. Yeah, it can. Okay, maybe it'll pass, according to Becca, but I'm not sure, to be honest. So let's see. So we have the same solution here. We're just using this here. We add our string key. We have our base case, right? This is our case here. Okay, let's see if this works. Okay, so I made it a little bit faster. I mean, we passed 27, but I'm gonna look at the comments. I love DP, said no one. No DP required here, basic maths. I don't get the beautiful byte hint. You will need to remove it the most 2 almost. Okay, so I have literally... Oh, bro, dude. I literally implemented the DP solution, but it went past, dude. So that's an L. Straight L's, dude. I don't know. I don't think I can implement this, dude. I don't know what the trick is, bro. Um, Yeah, guys, I'm not sure what the solution is. I don't know. I think I'm gonna have to watch a. I can't solve it. Open. No, what is it? Leetcoding. Oh my gosh, dude! I thought I was for sure gonna be able to solve this, bro, but.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, greatest sum divisible by 3. I'm going to try to make quick work of this problem. So the idea here is that we're given this list of numbers and we want to...
Okay, I think we have the idea. But...
that maybe guarantee two like lines of thinking that you could go down. The first might be like the brute force way, because how do you know what the maximum possible sum is going to be unless you try every single possible way? So some kind of like backtracking approach,
that's what we
and then
with,
maybe apply dynamic programming to that. And that's possible, but it's not like a trivial thing to do in this problem. There's the other line of thinking, which is kind of similar to yesterday's problem, where you use a little bit of the math to arrive at a greedy solution. And that's the approach I'm going to favor. I think we can get both approaches down to linear time and constant space. So that's why I'm going to favor this one. I think just intuitively it's a bit easier. So let's go ahead and do that. So
yeah,
I'm going to start...
took an L, dude. Fucking TLE, dude. I'm going to have a look actually before I look at a solution. Let's see... Okay, let's see what he's got here. First approach, recursion with Mimo, but using the take or skip. Okay, so this is what I did, the take or skip way, right? Did you see his latest video? I did. I watched like, bro, I literally watched like 10 minutes of it. Like, tiny bit, bro. Honestly, I got kind of bored, but I didn't see all of it. Add a Python code, add C code. Try the approach. Second approach, try to convert the recursive to the iterative one with considering the optimization for space. Third approach uses greedy. Iterative DP. What does he do here? DP. Bro, I cannot even read this, bro. Like, what does this even fucking mean, bro? Like, so this is the base case here. If I is less than 0, okay. He starts off at n-1, right? So that he's looping from the back for some reason. So I have a rough idea what he's doing here, but I mean, the way he's made this syntax here is a little bit confusing, but instead of returning the full sum, return only the BST remainder 0 sum from this point forward. I think that's what he's doing here. That's what Claude's giving me, bro, for a faster solution. I don't like those kinds of videos. I usually just say, fuck you. You don't get to tell me to quit. Yeah. I mean, I don't know. I didn't really, to be honest, bro, I didn't even really look into his video, but... Okay, let's have a look at what he did here. So, what Claude did. So instead of using a hash map, we're using a vector of integers. And we're kind of working with the remainder here instead, so... I don't really like this solution because it's not very intuitive. I kind of just go for the most intuitive solution. So how about we probably just finish?
Hey everyone, welcome back, and let's write some more. You mod it, and the remainder is 1. And this is where you might get a little bit tripped up. So I'm going to try to clarify this right here. What I've done so far is break the problem down into very simple terms. I took the entire sum and then I selectively remove elements to try to get the remainder to be 0, to make it divisible by 3. So I didn't have to do the whole backtracking approach where I pick or I skip, because that could get really messy. Then we might possibly remove like multiple elements. But what I'm showing with this approach is that we would never want to remove 3 elements in the first place. What's that ever going to do for us? We would just want to remove the one that has a remainder of 1. But there's actually a case where we would possibly want to remove 2 elements. Can you try to think of it? Well, what if there isn't any number divisible with a remainder of 1? Or better yet, maybe that number that is left with a remainder.
Other recurs and compute the best valid sum from index I onward given the... This keeps your recursive structure almost identical. Only track remainder 0, 1, 2. The sum remainder is all that matters for divisibility. Return the best valid sum from here, not the exact. Use int-min to invalidate non-divisible end states. This prevents skip options from returning 0 incorrectly. MIMO is now correct in tiny DPN3 at most 150 states. Okay, so I think I understand kind of what this is doing. Okay, let's kind of go with this solution. This is definitely a very unintuitive solution, at least to me. But I am no god at Leetcode, so... So this solution uses the remainder. I think this is kind of what he's gone about here, but he's looking at the greedy iterative solution. But I kind of want to stick to the DP solution because that's originally what I had. I just couldn't pass it because of the TLE. But alright, very common. So this creates a 2D vector with n rows. Right, and these are the columns here. All initialized with -1. Okay. So this allows us to hold 3 remainders, right? 0, 1, and 2. Call this DP, right? So that's fine. Call our backtracking function here, but instead we probably want to change that, right? So instead we don't need this key anymore, right? Whoops, we don't need this key. We have our base case here. So we have 2 base cases here. So instead of our case, instead of looking for something, we would go, well, if dp I remainder does not equal 1, right? We would just return dpi remainder. All right, we have our 2-dimensional array here. Int I. I guess we're tracking the remainder now instead. We're tracking the remainder of numbers. This is an interesting solution. This is I definitely would have not thought about this, but we'll take it. So here we still keep the same kind of structure here, right? We take it or we skip it, but instead of currently always keeping track of the total, we always keep track of the remainder, right? And this is how we would do it here, right? We go remainder plus nums I %3. Oh shit, dude, Steelers, bro. Yeah, bro. Steelers scored, dude. All right. Let's remove this here, right? So we have this backtracking DP solution. We skip it here, right? This stays the same, right? Because we're just skipping here. This is when we're taking it, right? We're always keeping track of the remainder, right? If the remainder is 0, then I believe we want to do something with that. Let's take a look here. So I was right. So instead of this here, we want to return. We have a little bit of a ternary operator here. So if our rem is 0, right, then we return 0. Otherwise, we take int min over 2. And I'm not sure why we do that here, to be completely honest. Yeah, I'm not too sure why we do that here, but let's fix this here before we take a look at that. DPI rem is equal to the max of take and skip. Then we just want to return that, right? I rem. Get rid of the res here. So I'm not sure why we do this here. I'm gonna take a look. We process all the numbers. What is the best possible sum we can return from here? Why we check rem is equal to 0. Represents the remainder of the total sum so far. Mod 3. Remainder is 0. An invalid sum if our remainder is not 0. Why return 0 on success? We return 0 because when a branch completes successfully, 0 additional sum at this final leaf. High recursion levels add the chosen numbers on top of it, so the total number sum is built on the way back up. So, from what I got from this, we want to take an extremely neg number and return and use this to avoid integer overflow. I guess that makes sense. This is very unintuitive, but still missing something here. I'm not sure how to debug it because I am not writing this myself. So, take a look here. DPI rem. We take here rem plus nums I %3 dp. Yeah, so it looks good. I don't know, to be honest. This is such an unintuitive fucking solution, dude. So apparently it's my check here. What the? Dude, what are we? What is it? So if dp I rem does not equal -1, return dp I rem. Dude, I'm doing the same thing. What are you talking about? Oh shit, I'm missing the -1. That's why. Bro, this solution doesn't even work. Like, going back to my solution. Fuck this solution. Fucking Claude's terrible, bro. I think that's my solution. Dude. Okay. So back to my original solution.
remainder of 1, the smallest one, maybe
so
it's
frustrating.
a 7. Okay, but maybe we have 2 elements in here. I think we're allowed to have duplicates, so maybe we have 2 elements that are 2. So 2 and 2. Well, the good thing about these guys is they sum to 4. So actually, this formula that I had was wrong. We're not looking for the smallest number that is left with a remainder of 1. We're looking for the smallest sum, the subsum, I guess, you could say, not like the total sum, but the smallest sum that we can get from this array that has a remainder of 1. And so now my claim to you is this: that smallest sum can only have 2 possibilities. Either it's going to be the smallest number that once you mod it, the remainder is 1, or it's going to be the smallest 2 numbers that when you add them together, the remainder is going to be 1. And so what 2 numbers added together could possibly have a remainder of 1? Well, you can use the intuition from yesterday's problem. Those 2 numbers would have to originally have a remainder of 2, because you take 2, that has a remainder of 2, and you add 2 to it, that also has a remainder of 2. So then you get 4, and obviously when you mod that by 3, you get 1. I could have done it differently. I could have taken 2 and instead replaced it with a 5. Why did I replace it with a 5? Because I just added 3 to it. So now I know that this number is also left with a remainder of 2. If I add these together, I get 7, and you mod that by 3, you also get a remainder of 1. So to make this more clear, I'm going to say the smallest n, where this is the case, or also the smallest n1 plus n2, where you mod these by 3 and you get a remainder of 1. Okay, so now that I've done that case, what if the remainder wasn't 1? What if the remainder was 2? Well, it's going to be pretty similar to this, except flipped. Then in that case, we want possibly the smallest n, where the remainder is 2, or we want the smallest 2 numbers, n1 plus n2, where the remainder is also 2. Either of these could be the minimum. And of course, we would want to take the minimum of these 2 and remove that from the total sum, because that's what's going to maximize our result. And by the way, it's not actually guaranteed that both of these are even going to exist in either case. Like we might end up in this case and maybe neither of these exists. In that case, what would we return? Well, we would probably just return 0. Same thing in this case. Okay, so now that we pretty much have the intuition of what we're trying to do, how do we actually do it? There's a few approaches I thought of, and the first one was honestly to use heaps, specifically max heaps. And the reason for that is because I wanted to track, well, in this case, we would just want to track the smallest number with a remainder of 1. In the same case, we would also want to track the 2 smallest numbers added together with a remainder of 1. Basically, that would be each of these numbers has a remainder of 2. So we want the 2 smallest numbers with a remainder. Do the same thing here. It's just going to increase the number. So we actually don't handle this case at all. We skip that case. So the other 2 cases is the number with a remainder of 1 or remainder of 2. So this is the part where you might think it's really easy to handle. So for smallest 1, we want to know the smallest number with a remainder of 1. So here, just minimize this and with n. So just take the minimum like that, right?
Bro, this is the most like interesting problem, bro. Like, let's see what this is rated, bro. Like, sorry, what is it? Leetcode. What is this number here? 1262. 1762, bro. This guy did dynamic programming. Like, bro, what is this, bro? Like, dude. I'm thinking my solution, bro, like, is gonna pass. Like, like, dude. Brain rotten on DP solution. Is it the same one? Yeah, it's the same one. Yeah, bro. I calculate the total sum of all numbers. At the same time, I keep track of two smallest numbers. After processing all the numbers, I simply return sum. Bro, this is making me pissed, bro. Like, bro, I've done some 1700 problems and... Bro. These are... just pure greedy. Let's take a look at the greedy solution. This looks a little bit easier to read. We want the maximum possible sum that is divisible by 3. So first we take the sum of all elements. It gives us the largest possible sum. Every number has a remainder when divided by 3. 0, 1, or 2. The total sum's remainder sum percent 3 decides if we need to remove something. If the remainder is 0, the sum is already valid. If the remainder is 1, we must subtract 1, mod 3. If the remainder is 2, we must subtract 2, mod 3. Bears are still losing though. Like, I get lost. DP is so fucking hard to track. Like, I get lost. I don't know, dude. I actually find DP problems pretty, like, straightforward to me. Like, a lot of the backtracking of DP problems, I feel like I have a good idea, but I don't know. Like, I mean, this is a valid approach to just TLEs, but I mean, to fix this, we only need to remove the smallest values. For remainder 1, remove one element with remainder 1, or two elements with remainder 2. For remainder 2, remove one element with remainder 2, or two elements with remainder 1. From these options, we choose the one that removes the minimum total value, so the remaining sum stays maximum. Yeah, I don't get it, bro. I don't get it. I don't get it. I think we're going to leave this daily problem, dude. I think we're going to take the L on this one. I think we're going to decide taking the L. I'm going to do the one from yesterday that I missed instead. I think it was an easy. Okay, find minimum operations to make all elements divisible by 3. You're given an integer array nums. In one operation, you can add or subtract 1 from any non-number of element nums. Return the minimum number of operations to make all elements of nums divisible by 3. Ooh. Okay. All array elements can be made divisible by 3 using 3 operations. Subtract 1 from 1. Add 1 to 2. Subtract 1 from 4. Okay. How can we do this? What numbers you can add or subtract 1 from any element of nums? Add 1 to 2. Subtract 1 from 4. Okay. Pretty sure we can just loop through it, honestly. In I is equal to 0, I is less than what size, I plus plus. Can we just do a simple loop here? Like if nums I is equal to 3, right? We can continue, right? Otherwise, right? If I don't even think we even need that if statement, right? Guess we can do, well, while if nums I is less than 3, right? We can just do while nums I, let's do like a count, right? Let's do like int count is 0, right? We can loop here, like if count is less than 3, sorry, no, my bad. Int count is equal to nums I, right? If count is less than 3, right? Else if count is greater than 3, we do this, right? I guess we can do while count is less than or equal to 3. Then we can go count plus or equal to 1. Right? We can keep a global count outside of here, right? This is probably a terrible way to go about this. Probably a way easier way, but it's whatever. What the fuck? Hang on. Private. Let's do like a int global count is 0. Right, we can go global count plus or equal to 1. Okay, that's fine, right? Otherwise, we do the same thing, right? Count minus or equal to 1. We take the global count. We're basically just going to increment. I think that should work. Probably terrible code, but... Oh, we're not returning anything. Return global count. Zero. So if num's I, so what are we missing here, right? We should get 2 here, right? Oh, subtract 1 from 1. So 0 can work too. Well, that makes it even harder. If 0 can work, right? Well, actually, this is probably a stupid way to do it, dude. We could probably just check, well... I think we can use the remainder, right? Right, if nums I percent 3. Hang on, let's do like int count is equal to nums I percent 3, right? If nums I is equal to 0, right? We can continue. Otherwise, else if nums I is equal to 1, the remainder is 1, then we just increment our global count by 1, right? And then else we would just increment our global count by 2. I think that's the intuition, honestly. Return global count. No, is that not the intuition? 7, 6. Hang on, I have to think about it. Let's go. Let's use this side of the thing. So if 3, 1% 3 is 1. So this would work in this case here. Of course, right? 2% 3. No, this wouldn't work. Oh shit, what am I checking here? Whoops. If count. Whoops. Let's do else if count is equal to 2. We do this. So I'm close. The thinking is close here. So maybe we just had 1. Does that work? Okay, maybe that's the solution, but I don't know why that's the solution. Will this submit? Okay, alright. I would have thought we would add 2 here, but I honestly don't know. how this works, and I'm not going to question it, but just make them equal to 0. Right, yeah. The reason why is because, okay, it's because we're negative, right? We can always subtract, right? So, yeah, okay, I understand. Anyway, we got it. So, anyway, I'm going to leave the leak code there, bro, because leak code's kind of frustrating. We're going to take a look at this here. I actually want to take a little recap here on model view matrices here. Just to get a little bit of a recap here, because I did this a few days ago. Been kind of off the programming. Model view matrices in OpenGL. Versus model view projection matrices in OpenGL. I'm gonna grab some water. Take a piss really quick. Take a piss, grab some water, check out my fantasy, bro. I'll be back. I'll be back in a second. Oh, so fantasy's not doing great. I am still winning, but yeah, fantasy's not doing great, but you know, it is what it is, bro. Bears are losing. Here's a clear breakdown. Projection matrix versus model view projection. H's OpenGL. projection matrix transforms coordinates from view space to clip space. Okay, that's what we did learn in China's video. This is the part that controls the camera lens, perspective versus orthographic, right? Talked about that. Field of view, near a far clipping plane, aspect ratio. It does not. Where objects are, how they're rotated, where the camera's positioned. Mathematically, projection matrix does. So if you only apply projection to your objects, will keep their original position / rotation only projected onto a 2D screen with depth preserved. The model matrix transforms coordinates from local object space to world space. This includes per object transforms. Okay. The view matrix transforms coordinates from world space to view to camera space. This is basically where the camera and what direction it is facing. Rendering OpenGL needs single matrix. Model view, MVP, model view, projection, matrix, the combination. When rendering OpenGL needs a single matrix. Projection times view times model times vertex position. Model put object in world, view put world relative to camera, transform view, clip space so GPU can rasterize. Okay, so I think I have a little bit of an idea, a general idea, but we're gonna keep progressing. We're gonna take a look at AMD.
With schizophrenia, it can feel like your symptoms decide what you do and who you can be. If you still have symptoms, be bold and ask your healthcare provider.
Hey, what's up guys? My name is Chano. Welcome back to my OpenGL series. So today's going to be a pretty cool and fun episode, I think. We're going to be integrating something called IMGUI, IMGUI, IMGUI. People say it differently. I say IMGUI. But basically what IMGUI is a GUI library kind of thing that we can use in OpenGL and DirectX and any kind of rendering API. It's pretty much API independent. It's a way for us to just draw UI on the screen. And by UI I mean things like buttons, text fields, color pickers, just information, windows, stuff like that. It's really, really useful for debugging purposes, and it's even useful if you want to make some kind of application quickly in kind of a real-time rendering setting. So like a graphics editor. Maybe like if we were making a game engine and we wanted to get a level editor up and running without having to actually make a Windows application using Qt or WPF or anything like that, you could even just make it using IMGUI really quickly and it would just run like a game, run like a real-time application, which is really cool. So link to IMGUI will be in the description below. The idea for today's episode is just to basically integrate it into our existing OpenGL code base. The reason we're doing this is because going forward, it's going to be really, really useful for us to have a UI kind of that we can just spin up really quickly for kind of debugging purposes. So for A, it's going to be really easy for me to just bring up values on the screen that we can see and edit, and then see that how that affects our actual graphics. But also for kind of debugging, if we want graphs, if we want frame rate, if we want kind of buttons that we can click that trigger certain things, it's really easy to kind of do all of that with a library like IMGUI, and it saves us having to write our own UI library, which, to be honest, can take like a really long time. So anyway, without further ado, let's just go in and take a look at what we've got. So if we kind of just run our code to see where we were at last time, you can see we had this channel logo and we had a model view projection matrix that we made consisting of a projection matrix, a view matrix, and a model matrix. As always, all this code is available on GitHub if you're a patron, so check out patreon.com/thechannel if you're not, and sign up to get all of this code individually per episode. That's where we're going to be starting from, the kind of model view projection episode. All of that code is going to be the basis for this entire episode. Okay, so the first thing we're going to do is get IMGUI. So if you check out the link in the description or just Google IMGUI, I'm sure you'll find it. If we go to the releases page here, I'm just going to download the source code for version 1.6. It was released 12 days ago at the time of making this video. So I'm just going to get the zip.
All right, let's grab this garbage. It's the latest release here. Where do I download this, bro? Releases? Isn't releases up here? Nope. Bro, where did he go to? Get this.
Archive release 12 page here, description or basis for this entire episode. Okay, so the first thing we're going to do is get IMGUI. So if you check out the link in the description or just Google IMGUI, I'm sure you'll find it. If we go to the releases page here, I'm just going to download the source.
Bro, where do you get the release here, dude? Like the better score, dude. I don't know. Dude, where do we download it? Oh, here we go. No. What's the .zip, dude? Should be able to build the examples from sources. Where's the source code? Why is finding the download link for this like the hardest thing, bro? Dude, are you fucking serious? Oh, dude, I thought it was a touchdown, bro. Jeez. Bro, where is the download link, dude? What is this? Can you download the source code anymore, bro? Or what? Zip. I don't know if I want to download the binaries though, dude. I'm gonna download. Is this the same one, bro? Man, am I stupid or where can I not find the download, bro? Demo. Calling the I'm sure demo function will create a demo showcasing a variety of features and examples. The code is always available reference and I'm good demos. Should be able to build the examples from sources if you don't let us know. If you want a quick look at some DRAM GUI features, you can download Windows binaries here. Get started. Bro. Shit's pissing me off, dude. Bro, am I stupid, bro? Like, in the later versions, I'm GUI v 9.0. The examples.cpp.h files are actually moved to directly called backends. I'm just thinking about downloading the fucking his version that he's got, bro. Honestly, like, he 1.60, dude. $1.90, dude. Page 20. No, it doesn't have page 20. Page 10. Page 5. Page 7. 1.69. 1.60. Okay, bro, is there a .zip here, dude? Assets. Source code. Okay, we're gonna do this, bro. I can't be fucked to figure out how to do it.
Source code for version 1.6, it was 1.6. Now there are a few things here that we care about. We don't care about all of this. Like, we don't really need all of the examples. You can see there's everything here from Apple to DirectX, a bunch of DirectX versions, old school kind of OpenGL, more modern OpenGL, Vulkan and SDL, and there's a lot of different things. We don't care about a lot of these. What we do care about is the OpenGL 3 example, because that one happens to be using GLFW, which is what we're using, and that's going to just make it really, really easy for us to integrate it quickly. And the other thing we care about is, of course, the actual IMGUI. So from IMGUI, what we actually need is all this stuff, basically. So if I copy all of these kind of CPP and header files that we have,
I guess I could probably just use the latest version, but it doesn't matter. Who gives a fuck?
Hello?
Yo, what's up, bro?
What's up, dog?
I'll come back in a second. I'm working on some stuff right now.
Alright, dog.
Alright, see you, bro.
Bye.
Okay.
have here, like that. So that's all of them. If I copy them, I'm going to go ahead and open my vendor folder.
Copy. stbrec.h. hack.h.
Here, like that. So that's all of them. If I
Oh, you got some other ones too. All the files. Okay.
copy them, I'm going to go ahead and open
Okay, let's move this to source vendor. GUI.
my vendor folder. And then from here, I'm just going to make a folder called IMGUI, and then just paste in all of my code into there. So the other thing that I wanted was that GLFW example. So if I go back to this zip file and into examples, and where is GLFW? So OpenGL 3. I'm just going to grab these two. Now, we don't really need main. I'll copy it out anyway. We don't want it or anything, but it is a good kind of example that we can just use. So if I go back here, I'll paste all this stuff in. Main, again, we're
Dev OpenGL.
going to delete, and we probably just won't include in our project, but it's still useful to have there for reference. Okay, cool. So that's all we need for IMGUI. It's really, really easy to set up. If I go back to vendor, I'm just going to hit this refresh button up here at the top. And I'm going to basically include everything from here. I'm just going to exclude that one main.cpp file because we do not want that. So exclude from project. But again, we'll keep it around here for reference. Okay, so to set this up, if we take a look at this GLFW example here, one thing that it does is it actually uses GL3W instead of glue. We're just going to change that. So we'll get rid of this comment.
What is he using? IMGUI. This one.
And we'll change this to be GLEW, and I guess I'll change this comment here as well. That's pretty much it. If I hit Control F7, this should just compile, and you can see it does. So let's try compiling the whole project now that we've included all of these IMGUI files. Hopefully everything works fine. And as you can see, there we go, no errors. Let me just drag this output window over here. No errors, everything is fine, beautiful. So now we just need to integrate it into our application. So to do that, a really easy way to do that is just to take a look at this main.cpp file that we excluded, because that basically has an example. So really all we need to do here is we need to create the context for IMGUI. We need to call this glfw3 init. That function is found inside this glfw3 example that they have here. And you can see it registers all of these kind of key bindings. It takes care of that for us. You can see that all we have to do is pass in the window pointer into init, and it will just set up all of the input bindings. So it's really, really cool. Style colors dark, sure, why not? And then it's got some examples on actual usages. As for our run loop, we just need to start a new frame, and at the end, we just need to basically end the frame using IMGUI render, and then render draw data for glfw3. And that's pretty much it for all of the draw data, so that it actually renders it using OpenGL. And at the end, we can do shutdown. And that's pretty much it. So if I just dock this side by side, let's go ahead and start copying some of this code. I'm gonna zoom out a little bit. Hopefully you guys can still see everything.
Oh shit, dude. Application.cpp. How do we dock this, dude? Hang on. Figure out how to dock this. Alright. I'm gonna move this on the other monitor really quick. Move it back after we're done with this part. Oh, bad touchdown, but there's a flag.
This will just be for a bit while I copy this stuff. But basically, let's grab that create context that we have here, and we'll put it at the top.
Create context.
So right before we do our loop here, maybe after we create the renderer, say, I'll call IMGUI create context. Now we need to include this. Because it's in our vendor folder, we should just be able to do include IMGUI slash
GUI slash
IMGUI.h, and we'll also have to include that glfw3 example. So
GUI.h hashtag include GUI slash
this one here. Great.
GUI. I'm gonna quickly turn on the TV, maybe it's a bit loud.
Okay, so we create the context. We're then going to initialize this. So we'll just pass that in. You can see
initialize this. Let's grab that.
I mean, it's even called the same. It's even called window in both examples, so we literally don't have to change anything. We'll go ahead and set up that style and set it to dark. And that's it for the initialization. Let's go ahead and start a new frame. Now this doesn't have to be, this has nothing to do with starting a new frame in terms of like a new GLFW frame. It's just for IMGUI, so we can just put this here. It doesn't matter. I'll put it after the.
Set up a new frame, bro. Okay, here's the code for that. IMGUI W3 new frame.
renderer clear. You could put it anywhere, just make sure you put it like in between your IMGUI code. So before you start any IMGUI code for this frame, you want to have the new frame function call. And then at the end, there's IMGUI render and then that kind of render draw data thing. So I'll do that right before we swap the buffers.
IMGUI render.
And then finally we have a shutdown. So there's 2 lines for that, and that's right before GLFW terminates, so we'll put it right there. That
GUI renderer.
That is it, okay? So now let's try and render a window. This main example also has that, which is beautiful. You can see there's a bit of a window over here. Let's copy that. I'll put it after, I might put it after we render everything. So maybe right over here.
Where's this code? Yeah. GUI code.
And then there are a few variables up the top here that we want to also copy.
Window.
Let's just put that here. And let's close main. I'll put the text size back up. Let's hit F5 and see what we get. Okay, so check that out. That was really
cool.
easy, and you can see now what we have is this window that we can kind of move around, and everything's pretty beautiful there. So we can change the color. I can even click over here and adjust the color of everything. Now you'll notice that it is a bit offset from my mouse pointer. That's actually this laptop. For some reason Windows DPI scaling or something. I don't know exactly what's going on, but the mouse pointer is just offset for a lot of applications. If I even open something like Mischief up, which is a paint drawing app, you can see that it draws way offset from my cursor when I'm at the top of the screen. And then if I kind of go down, it kind of matches. I don't know how well you guys can see that, but if anyone knows what on earth is going on here, it's been really frustrating. It's just this laptop. It's not the only kind of high resolution 4K whatever laptop I've got either, so I'm not sure why, but it's just this one that seems to be completely wrong. So don't worry about if your IMGUI should be completely fine. But you can see that, yeah, it's even got like color pickers, and this is just an example of kind of what you have here, and then all of these settings, and like, yeah, we can drag this around, we can resize this window however we like. I just need to find my mouse pointer. This is so annoying. There we go. So yeah, that's IMGUI. This is a great example of how it works. Now, let's actually do something useful with it in our code. So I'll get rid of all this kind of example stuff that we have.
Okay, let's get rid of
have here. This whole example window we don't need. One thing I will keep is this, I guess, this slider float, because that'll be useful. And I'll get rid of everything, and I guess we'll keep this
Slider float. I'm GUI text.
Frame rate thing because it's kind of useful. Okay, so now one thing I want to do here is we've just talked about model matrices and how we can use them to translate our actual geometry. Let's go ahead and make this kind of model matrix something that we can actually edit live. So to do that, I'm going to copy basically these two lines and paste them over here where we actually do our uniform submission. So we need the model matrix and then we need the MVP. And then what I'll do with that,
let's move this back on the screen.
And paste them over here where we basically these two
Model MVP
lines and paste them over here where we actually do our uniform submission.
Here? Wait, what was it? Alright, before we do the new frame. So here. Okay.
So we need the model matrix and then we need the MVP. And then what I'll do with that is I'll just get rid of the model matrix from here and the MVP from here. I'll cut this MVP line. This actually uniform setting, and I will put it over here with the other uniform. So now we're basically just recalculating the model matrix and the MVP every frame, which is totally fine. So now let's add something to IMGUI that lets us actually kind of modify this. So right now it's just a GLM vec3, and that's something that we're passing into this translate GLM function.
Model the MVP, okay.
I'll cut that and I'll put that outside of our run loop. So maybe over here. Yeah.
Where's he getting
I'll
that
cut
vector
that,
from?
and that's something that we're passing
GLM vector.
into this translate GLM function. I'll cut that and I'll put that outside of our run loop. So maybe over here, and I'll call this translation. We'll still start it at 200, 200, and 0. And if I go back, call this translation. We'll still start it at 200, 200, and 0. And if I go back here, I'll paste in translation.
I'm making a variable name here, okay. So translation.
And then into IMGUI, I'll use something called a slider float 3. Probably just use a float 2 because we just care about X and Y. But we'll use a slider float 3. And I'll pass in the memory address of translation X. Now I'm not really sure.
Hang on. Translation .x here. So it's a... Okay. Anyway.
Sure, this takes a, you can see this takes a float array.
Translation X 0F. Let's get rid of these fucking comments. Piss me off. Okay.
I'm not really sure how to get that out of GLM though. If we look at if we look at what a vec3 is, that's for low p. Okay, high p vec3 is just a type def of vec3. You can see that The thing that it's using is just a union of t, x, y, z. T is float, so we have x, y, z. It's pretty much how you would expect a vector tree to be laid out. The reason it's a union is, of course, just so that we can basically address it by either x, y, z, or RGB, or STP, whatever kind of variable names we want to use. And they, of course, mean the same thing. But I can't really see anything, I was looking through this a bit earlier, that returns an actual array, like a pointer to everything. You can see this just returns t. So I'm not exactly sure, maybe there is a way, but right now I'm just going to pass in the memory address of the first variable, which is x or r, whatever you want to use. I'll just use x, of course. And that's just going to give it the memory address of x, and then of course the next one in memory is going to be y and z, so everything will work as expected because the memory layout is the same as a float array. Okay, so anyway, the bounds that we'll set are maybe 0 and 960. 960 because we have our projection matrix, I believe, set to be up to 960.
What is mine set to, bro?
And that's, we have our projection matrix, I believe, set to be up to 960.
Mine is up to, what, 2.0 float. So mine should be 2.0 0 float.
And that's really all we have to do. I mean, of course, this is basically setting up
for how many days have you been learning OpenGL and working on this project? I've been learning OpenGL. I've been doing it pretty slowly. I'm up to episode 22 of Chono's series. So yeah, bro, just been probably doing it about a week or two, I would say. The goal is to, you know, I'm trying to learn a little bit, kind of get the fundamentals going, and then the plan is to make a project. Probably something in 3D I'm kind of interested in, so, or even in 2D. I've already done 2D games before, but never something in OpenGL that's 2D, but, you know, maybe we might try and explore something in 3D. I don't know. Just trying to learn, create something. I'm interested in graphics programming, so I'm just trying to teach myself. And I kind of started off at learnopengl.com, but you know, I thought I kind of like more visual stuff, so I kind of wanted to go through Chono's series. Plus, he taught me C++ and everything pretty much, so yeah, I think he has a good series.
component slider that we can use to modify this translation vector, which is being passed into model and being used for our MVP matrix, which we pass into our shader. So everything is kind of linking up. If we hit F5 to run our code here, you can see what we get is this. And if I move this window out to the side a little bit, what I can do is change this. Okay,
let's see if this fucking works, dude. Oh, looks good. Nice. Cool. So I've obviously messed something up here. I think it goes to 2.5. Yeah, 2.5. I think that's what I messed up here, but it's fine. I mean, this is just a learning thing, so. Application average frame rate, 60 FPS. Okay. Cool.
Value here, this is the X position, this is the Y position, and you can see that it moves everything, right? And if I put everything to 0, 0, you can see it's not really quite the bottom here, and that would be because I think in our vertex buffer, yeah, you can see we don't actually hit the bottom anywhere. We're kind of at 100 by 200, so that is why that's not in the very kind of bottom left. But anyway, yeah, that's a great example of why IMGUI is really useful. It just lets us quickly bring up stuff like this that we can control while our actual code is running, so we don't have to keep recompiling. And it's really going to help me to show some of these things that we cover in this series in a bit more detail. Now, unfortunately, I hate this mouse offset thing. Maybe I can actually think about solving that for next time. But I hope you guys enjoyed this video. If you did, you can hit the like button. You can also help support the series by going to patreon.com/thechono.
I mean, there wasn't a lot in there. Just kind of implemented
as always, the code for every video goes up on GitHub, and if you're a patron, you can access that. So be sure to take a look at this code if you want to make sure you didn't make any errors or anything like that. It was really, really simple to integrate IMGUI. I mean, you saw how easy it was, really no big deal. If I was kind of writing my own engine, I probably may have rewritten their kind of GLFW thing to also include other APIs like DirectX or whatever I supported. So This series is obviously just about OpenGL. I just thought I'd throw IMGUI in because it's going to help me explain a lot of OpenGL concepts a lot easier because I can kind of manipulate things live. But anyway, next time, what are we going to move on to next time? There's so much to cover. You'll have to just wait until next time and see what ends up happening. I'll see you then. Goodbye.
Alright, let's jump to the next one. Render in
Liberty
multiple
Mutual
objects.
customized my car insurance, so I only pay for what I need. What a great day.
Hey, what's up, guys?
Alright, stick with it.
Guys, my name is Chano, welcome back to my OpenGL series. So, today we're going to be talking about how we can render multiple objects on the screen. So far, all we've really done is we've rendered that Chano logo on the screen once, and we haven't rendered more than one object. So we're going to talk about what it takes to actually render another object, or the same object, maybe at a different position or an entirely new object, and how in general we can go about rendering multiple things. This is going to set up a bunch of things for the future, as all of my videos seem to do. Don't worry, at the end, in like 100 years from now probably, it'll come into it'll all tie in nicely, and you'll understand how everything works, hopefully. But yeah, so this will be kind of important for things in the future, and also it's just a good thing to kind of talk about initially before we dive into it. So if we take a look at our code, I'm just going to run it real quick so we can see what we have. We basically added IMGUI last time so that we had this kind of debug overlay. By the way, I solved that whole mouse pointer kind of being in the wrong place problem. That was because I was using the Intel GPU inside my computer. I switched to the NVIDIA one and it works fine, so clearly it's something to do with Intel's drivers. I might make a video in the future talking about that, but it's perfect now, as you can see. Anyway, so we have this channel logo being rendered, and we've got this model matrix that we're modifying here using IMGUI, and everything seems fine. Basically our goal for today is going to be to render another one of these at a different position, and we'll see what it takes for us to actually do that. So if we look at the code, nothing really too complicated is going on, but if we take a look at the code that actually draws that channel logo, it's this line over here. So we do renderer.draw, and if I just kind of alt F12 into that, so you can see both, you can see that we basically bind our shader, we bind our vertex array, we bind our index buffer, which actually isn't 100% necessary because the vertex array already has a binding to the index buffer. But anyway, and then we actually issue the draw call, which is this line over here, which draws that channel logo onto the screen. Now, here's the thing. The thing that determines where this channel logo gets drawn, or in fact, let's just discuss these three lines first of all and what they actually mean. So shader bind is important because it binds a program for our GPU to actually use to render whatever we're trying to render. That's the shader. The shader, a lot of people, again, think of shaders. It's really important that you actually understand what shaders are. Shaders, which are also called programs by OpenGL, are literally that. They're a shader program. They're something that allows us to say how something will be rendered. We're basically telling the GPU what to actually do. That's really important. It goes way, it's nothing to do with like lighting or shading or anything like that. It's literally just us giving instructions to the GPU as to how and where and why and whatever we want to actually draw what we're trying to draw. So that's really important. That's step one. Then we bind the vertex array, which is, again, the array that contains all of the actual data. So the program or the shader says what to do with the data, and this vertex array is the data that we're going to do stuff with. So this includes our vertex buffer and our index buffer. That's all that we've got at the moment. Vertex buffer, of course, contains all of the vertex data, including the positions of each kind of point that we're trying to render, texture coordinates. I think that's probably all we've got, but if we were drawing something a bit more complex, we might have other things in there like vertex colors or normals or binormals or tangents, or there's a lot of things that you can put into vertex data, which we will get into in the future. The index buffer, of course, contains the indices into the vertex into the vertex buffer, so that we actually know like what to render. The index buffer contains the indices into the vertex buffer, so that we can choose which vertices we actually want to render and how to kind of assemble all of them together. And then finally, draw elements just says, hey, using that index buffer, access the vertex buffer and call the shader program on all of those vertices individually to actually get it to draw and eventually rasterize our object onto the screen. So that's kind of a bit of a summary of what it takes to render that one kind of Shono logo. So if we want to render another one in, like it'll look exactly the same, but we want it to be somewhere else on the screen, how do we do that, and what do we actually need to change? Well, okay, let's think about it. First of all, the shader. Does that need to change? Well, the shader is kind of, if we take a look at what our shader even looks like, it's just this thing over here. The vertex shader just takes in a bunch of data from the vertex buffer, which is this part over here, and also just directly from our CPU as uniforms. And then, sets GL position, which determines where the vertices are going to be, and then also outputs this texture coordinate to the next stage of the shader pipeline, which for us is the fragment shader, which basically takes in that texture coordinate from the vertex buffer, from the vertex shader, and then also takes in 2 uniforms from the CPU, and then just basically samples the texture using the texture coordinate and outputs the color that it retrieves from that texture sampling into this output color over here in our final frame buffer. So that's what our shader does. So if we think about the shader, is it specific to any kind of position? Well, no, because it takes the position in from somewhere, doesn't it? Well, let's look at where it gets the position from. So the first thing you might notice is that, yes, we have a position attribute up here, which means that this is coming in from the vertex buffer.
Playwright tool. What the fuck is that? Why isn't this loading?
So what we could do, as just one of the ways that we could do this, is we could supply different vertex positions. Now, what that would require is having an additional vertex buffer, because we would need to create a second vertex buffer which contains all of the positions of the second instance of the Cherno logo, and then we could use that to actually put them somewhere. And that would work, that's fine, that's one way to do things. Let's see if there's another way. So the other thing that actually happens here, you can see that this position also gets multiplied with this uniform, which is our model view projection matrix. So what we could also do, instead of changing that attribute and that vertex buffer, is we could just change that model view projection matrix uniform, right? We could basically just provide it with a matrix that had a different transformation applied, like a different model matrix essentially, which positioned our object somewhere else in the scene. And then when that got multiplied with that existing kind of vertex attributes that we have, those existing positions, it would put them somewhere else on the screen. So that's kind of the two ways right now, or rather two pieces of data that we could actually modify in order to get the two Cherno logos to show up in different places on the screen. So in this case, what I would do is I would leave the vertex buffer alone. And in fact, right now I think it's set to like 100, 200, or like it's not kind of normalized. I'd probably just set it up to be centered around 0. And then I would just provide two different model view projection matrices to actually position them somewhere else on the screen. Because having two vertex buffers is an unnecessary kind of memory usage that we have in our GPU.
Hey, been watching your streams. for a while now, and I love your consistency. Oh, thank you, bro. Appreciate it. That's super kind of you. Yeah, I try. I only stream like probably about 3-4 times a week nowadays, but you know, once I start my full-time job January 5th, I plan to kind of stream in the evenings after every day, so that's the goal. But yeah, I appreciate that. Obviously, you know, right now not as much as I was streaming you know, when I was doing the programming every day until I get a job. I mean, I was doing that every day literally except for the weekends, but appreciate that. Thank you. Happy to see you back and keep checking out the stream. So thanks, bro. Appreciate it.
And also we need to rebind them, which is not as fast as just providing a different uniform. In fact, it's pretty common to just provide a whole set of different uniforms every time you draw. Whereas a vertex buffer, we don't necessarily need to change it in this case, so we don't need to actually worry about that. By the way, I did just say that rebinding a different vertex buffer is slower than uniforms. That's not actually true. Sending uniforms over to the GPU actually involves transferring data from the CPU to the GPU. So I didn't actually mean it's physically faster to do that. I'm just talking about the fact that we don't need to have two redundant sets of data that we need to bind between, and basically it makes it feel like we have two different objects. In this case, it's a lot easier for us just to provide a different model view matrix, and that's it, a model view projection matrix, and that's it. So let's take a look at how we might do that. So if I go back to our application or CVV, what I'm actually going to do first of all, I'll close this renderer thing view, I'm just going to think about these positions that I've actually supplied here. So these are all texture coordinates. They're fine. We don't need to worry about them. But what we have here is we have a 100 by 100 pixel or unit. In this case, 1 unit is 1 pixel. Square here. So what I'm going to do is I'm going to make it so that it's centered around 0, 0. Because right now it kind of goes from 100 to 200, and that's not great. Because it means that if we provide any kind of translation to it, it's going to be from this.
I think mine is fine here because I'm doing something different to him, so I think mine's okay for this point.
As the origin.
So I'm going to leave mine as it is.
Origin that's actually 0, and I would like our origin to be 0. So what I'm going to do is, because it needs to be 100 by 100, is I'm going to make the kind of left bound and the bottom bound -50, and then the right bound +50, because that gives us a 100 by 100 square. So I'll change this. Basically anything that is 100 needs to be changed to be -50, and everything that is 200 needs to be changed to be +50, okay? So this is going to become -50, and this is also going to be -50. I'll change all the 100s right now to be -50, just like that. And then these are going to become +50s, and I'll just leave a space here so that everything kind of lines up perfectly. Okay. There we go, done. So if we just hit F5 to look at this, what we should see is, because 0, 0 is the bottom left of our screen, if I set the position of this to 0, 0, what it should be is kind of centered around that 0 point. Now it's a bit hard to see, and additionally I think we have a camera.
See, mine's fucked up here, but I'm honestly not sure why. I think it's because I go to -2.5 in the projection view matrices, but I'm not really fully 100% sure, to be honest. I don't know. Maybe that's something I can debug later.
Transformation applied. So if I just hit stop here real quick, and I take a look at the model view projection matrix that we're actually supplying. So this is our view matrix. You can see that it's translated -100. I'm not going to worry about that. What I'm going to do for now, for the camera, is just leave it to be a translation of 0. So I'll kind of leave all this code here. It is a bit redundant because obviously we have no...
Man, I still have to go through and try and understand this better, but it's like, these numbers here are confusing as hell. Let's see what happens if I do 0. Okay, so that's kind of odd, but alright. What if I had it? What was it? I think it was 1.0. Bro, what did I have it as here? Oh, float. Whoops. Negative. That's what I had it as. That puts it in the middle. Zeros here. 1, 2. Because I think that's the reason why, because I only go to 2.0 here. So if I increase these to 2.5, I think this should work maybe. Nope. Okay, so what if I did it the other way? What if these were 1.5? 1.5. I have to study this stuff a little more, but it's like, fuck. Oh. Okay, that makes the square bigger. Okay. Well. Oh, shit. What did I just do? No, bro. What did I just do, dude? What did I do? 960F. I think it was 1. Yeah. Oh, this was 2. This was 2. Happy for you, bro, on your new job. What's your advice to someone learning to get the skills to get job offers? It's my advice. Well, to start, I am nothing amazing. You know, I'm probably the most average dude there is. I would just say, bro, you just gotta show that you, like, love it, bro. Like, if you're passionate, man, and you love to, like, learn and, you know, teach yourself things, I think that goes a long way than someone that kind of just does it for, you know, just for whatever, right? I feel like you really gotta love the craft and, you know, just be consistent, bro. Just, like, work at it every day. You know, work on something, no matter how big or small it is. Like, I would also say lead code every day, you know, depending on what your level is. You know, I'm nothing amazing. I used to do a lot. You know, now I just kind of do the daily problem every day. So, you know, just being consistent with that, you know, keeping your the ability to pass, like, the technical interviews, like, high. And just be passionate, bro. Work on projects, work on things that interest you. I would recommend working on something that has a user base. If you can have some sort of project that has a user base, I think that goes a long way too in the interviews. When you talk about something, you actually have real people using your stuff. But yeah, above all, man, the most important thing is just to be consistent and just to love what you do, bro. And I think that goes a long way over anything. So that's my advice for you. Hopefully that's okay advice.
Translation, so this matrix is just an identity matrix, which means that we might as well not multiply it at all, but we'll change this stuff in the future. That's why I'm leaving the code in. So we have this over here, and it just got a lot darker outside, and now it's raining. So if the lighting in this video changes, I'm sorry, but that's how Melbourne weather works. Okay, so this view matrix is basically just, we don't have any transformation applied to our camera. It's just in the kind of middle, it's in the default position, which is just 0, 0, 0. So if we look at this now that we don't have that transformation, if I just set this to 0, 0, you can see that basically this channel logo is kind of center point is that 0, 0. And of course it goes -50 outside in both X and Y. So that's where we're at right now, just so that we're on the same page. So now what I'm going to do is I'm going to render this thing.
Map for 1.0. What is he rendering here? He's got a
twice, except what I'm going to do is change that model view projection uniform here. So the color we can leave the same. Color does not matter at this point because we're rendering a texture anyway, and we're not.
He's in the main method, right? Yeah.
Not tinting it by this color or whatever, so this is just, might as well not exist. In fact, I'm probably going to stop setting it because it's just...
New color. I'm going to keep mine though.
So this is just, might as well not exist. In fact, I'm probably going to stop setting it because it's just confusing in terms of code. So I need to bind the shader. Now, you'll note that, of course, render a draw does actually bind the shader. That's all fine but we need to set up uniforms. And in order to set uniforms, we need to have an active shader bound so that we can bind them to the right so that we can bind the uniforms to the right shader. So we need to basically draw. So first of all, we know that shader bind already is activated here, so we don't need to bind again. So what I'm basically going to do is I'm going to bind my shader, and then before I draw, I'm just going to set this uniform.
So he does it twice here. Render.draw PAIB shader.
Form twice, like this, right? So before every draw, I'm setting that model view projection uniform. Now, what I need to do before I set the second one is, of course, actually change it. So what I'm going to do is, we have this model matrix here, which is kind of our first translation. What I'm going to do is go up here to translation, copy and paste that. I'm going to call this translation A and translation B. I'm going to put this one maybe at 400x instead of 200x. And then if I go down here, 100x.
I gotta piss really quick, guys. I'll be back in a second. All the Bears, touchdown again. We might win here, bro. 1 second, I'll be back in a second. Oh, okay, I'm back.
X instead of 200x. And then if I go down here, I'm going to use translation A to get the first model matrix here. And that's what we're going to actually send. And in fact, just to keep this a bit clean,
So my full model 4 translation.
I'm actually going to enclose this in a scope along with that set uniform mat 4, just like that. Okay?
Okay. I'm trying to think what we're doing here. Translation A. Oh, I don't have that code. Where is that code? Shader.set uniform. This is something I'm gonna have to go through, I think, again. Let's move this inside here. Okay, so he shader.bind over here. Shader.bind. Whoops. Shader.bind. We have the model matrix. Right. This is the color for disco. Right, we have our GUI code here.
And so that's basically us setting the first uniform, and maybe I'll even put the drawer into this.
So really we need this code here. Right. Let's get rid of this. We shaded our bind. I'm gonna move this for the draw call. Bind the colors, we draw. Let's get rid of that. We draw the square. Let's get rid of this.
Scope so that it kind of makes sense. This is kind of one operation to draw. And now I'm going to do the exact same thing to what we have over.
I guess we need the color for the disco to be above here as well, technically, right? So let's move that. Like that would make sense. This is the GUI code.
Over here. It's just that we're going.
So then we are doubling this here. So I guess
now I'm going to do the exact same thing to what we have over here.
Okay, let's just fucking double this though, and why not? Model matrix. Let's draw call 1. Right, this is draw call 2.
It's just that we're going to use translation.
Translation B.
B instead. So identical,
We're not going to use the color though, so we can get rid of that.
same thing, it's just that we're using translation B instead. Okay, and we need this shader bind really only for the first time we run through this loop, because draw will bind that shader and never unbind it anyway, and since we're not binding additional shaders, this will all work. If you want to make this code a bit more robust, it would be wiser to actually move that into here.
Shader.bind. Oops. Shader.bind. 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 Let's fix this. Cool, dude.
Again,
I think we can get rid of this crap here. Okay.
if you call bind shader on a shader that's already bound, that's a bit redundant, that's a bit slow, that's a bit of a waste of performance. Usually in more complicated setups, such as an actual game engine or a graphics engine, you would have some kind of caching system that would be like, hang on a minute, you're trying to bind the shader that's already bound, that's redundant, I'm just not going to run that OpenGL call. We don't have anything like that set up, obviously, but it'll be fine for this example. Okay, so translation A and B set up differently. And now what I'm going to do here is, as I fix these IM GUI errors, I'm actually going to make sure that we have translation A, and I'm also going to add translation B in.
Translation B. I need to learn these shortcuts, bro, that he's got. Translation B.
To this IM GUI window as well. So we'll have A and B, just like that. Now let's hit F5 and see what we get. Alright.
Alright, so his works. Let's see if mine works. Mine was a little different, so let's take a look. Okay, I did it. Perfect. Okay. Now we have multiple objects on the screen. We still have to figure out exactly what's going on here with the sides here, but...
This out. So we have two Cherno logos. Let me just move this out of the way. And if I modify that first one, you can see it moves the first one over here, and I can move it up and down or left or right. And then also the second one over here is modified via that second slider that we have over here. Pretty cool stuff. So that's basically it. That's how you render two objects. Really, all we're doing here is we're rendering the exact same object twice. We're not changing anything except for a single uniform. And the reason we're doing that is because we want it to show up in two different positions on our actual screen. Now, you might be thinking, okay, well, cool, that's how I render multiple objects. So if I wanted to render some kind of tile map, maybe I'm making like a 2D game and I have like this kind of level that's just a tile map, I guess I just write a for loop that goes ahead and does this. No, this isn't the solution to rendering everything, because if you do that, if you just have a for loop that renders 1,000 tiles on the screen, that's going to be pretty slow, because that's 1,000 draw calls, and it's just that it's not going to be fast at all. You'll probably notice very poor frame rates. I mean, it still probably will be above 60 on decent hardware, because there's nothing much to render here, and 1,000 draw calls on a PC isn't awful, but you can actually draw that in a single draw call by doing something called batching, which is where you actually shove all of your tiles into one vertex buffer and then have kind of, instead of doing it the way that I did it here, which is I'm just changing the uniform, you can actually do the other method that I mentioned, which is basically, instead of having, we're basically changing the vertex positions that are in the vertex buffer. And if you set that up, but instead of having two different vertex buffers, you shove it all into one vertex buffer, and then you kind of just render everything all in one go, and all the data's already there because the vertex buffer is just very large, and it contains all the positions for every single tile you have. That will be 1,000 times faster than if you go ahead and you bind a shader, you change the uniform, and you do GL draw elements for 1,000 tiles, okay? And we are absolutely going to explore doing that kind of batch rendering method, because it's like, for 2D games, it's a must. For 2D rendering, it's a must. Even if you're rendering like layouts or like kind of, text, UI, stuff like that, for text, it's vital, because every kind of character that you render in text is a separate draw call, or it's a separate like quad, and we don't want them to be separate draw calls. So we'll definitely cover it in the future, very soon probably. But the reason I did it this way is because this is kind of probably the way that makes sense, and it's probably the most simple way. And it's also really, really useful if we were rendering 3D objects that were quite complex. This is 100% how we would actually do that. And additionally, it opens up one of the most important things that we need to talk about, which is the thing that is different about these two objects is just the uniforms. So what we need to eventually get into is something called a material. And a material is really just a shader and a bunch of uniforms. And we'll get into that in the future. So leave a comment below as to if you want me to continue with this kind of 2D stuff and cover the batch renderer in the next episode, because I'll probably end up doing that, I think. But otherwise, we might talk about materials and start getting into some more exciting things like that. Both topics are very important, and we'll have to cover them anyway, and they're very exciting. So just leave a comment below and thumbs up any comments that mention which one you agree with, and we'll see what we can do for the next episode. Anyway, I hope you guys enjoyed this video. If you did, you can hit the like button. You can also help support this series. It's physically far, the kind of left bound and the bottom.
Shit, dude, I missed this part in this thing. Shit. I must be in the I'm GUI series, but I don't know. Fuck it. I'll look at it tomorrow. I'm gonna watch the rest of the Bears game, so I appreciate you guys watching. I'm gonna keep working on this. Probably go through a couple more episodes. I should be streaming tomorrow, so you guys want to join in again? That would be cool. You guys should follow my GitHub. It's in the description below, or join the Discord if that interests you. But appreciate everyone watching. Yeah, all my stuff's in the description, so appreciate you guys watching. Peace. I will